Hello everyone, welcome back to another video in our series on ML. This is our first unit for machine learning, and this unit in particular will be focusing on polynomial regression. So we're going to start with linear regression, and in particular we're going to be using scikit-learn. So to get started, I have a bunch of import statements, so pandas, Altair, and Seaborn, all things we've seen before, and I have a couple of exercises just to get us started. So first thing is saying import the taxis data from Seaborn. So I'm going to say df equals sns.load underscore dataset, and now let's get the taxis dataset. As a reminder, we can see, well, what is the taxis dataset? What does it look like? And we'll wait for this. So you can remember it has things like pickup and drop off times from taxi rides, number of passengers, the distance traveled, how much the ride cost, and a whole bunch of other information. So next thing we want to do is drop rows with missing values. So I'm going to say df.drop NA, and I can say in place equals true to have it just replace it for me without having to do something like df equals df.drop NA. So this is looking good so far. Now, next part is saying, using Altair, make a scatter plot with fair along the y-axis and with distance on the x-axis. So I'll write the code for this, and there's going to be an error. So we'll get the error and then talk about it. If you're reading ahead, you can probably guess what the error will be. But I'll say alt.chart ef.mark circle .encode. And let's see, so we want x-axis to be distance. And we want y-axis to be fair. I run the code, and Altair is saying the number of rows in your dataset is greater than the maximum allowed 5,000. So it's saying for information on how to plot larger datasets in Altair, see the documentation. I have seen the documentation, so this warning is basically saying if you want to do something with more than 5,000 rows, think carefully about it. Think of some of the drawbacks and hazards of working with such a large dataset for plotting. But for us, let's just choose 5,000 random rows to avoid the max rows error. So all I'm going to do is I'm just going to copy paste this, and I'm going to say df.sample and then 5,000. Now, I'm not using a random state here to get reproducible results or anything like that, just because a general idea of this data set is what we want. So looking at this graph, we see distance versus fair, and it's not perfectly linear, of course, but it looks like it's well suited to linear regression because we can kind of see this line going like this. Couple of strange things about this data set and kind of what was pointed out during our lecture is when we add a tooltip, we'll see there's a number of taxi rides where there was a positive fare, but a zero distance, which is a little bit strange. In our live lecture, we took out these points from the data set. I'm going to perform the regression with them just because I've done it both ways and it doesn't have a huge effect on it, but still a little bit strange. Maybe you can think of a situation where that happens. Another strange thing happening here is other than so most of the data seems to follow this line, but there is this horizontal line here. And if we add a tooltip, we can figure out what's going on. So let me say tooltip equals, and let's add pickup zone. Let's add drop-off zone. And let's do distance and fair. So now I'm going to mouse over this horizontal line. And if we kind of scroll through, we can see these are all kind of pickup drop-offs that deal with the airport. So I think what's happening here is it's some kind of fixed fee to get to or from the airport. So that's what's going on here. Just this one case, but everything else looks to follow this line. So there wasn't kind of a deeper linear regression reason for including the tooltip. I just wanted to show you kind of an explanation for the strange behavior. Something else weird, notice here we have a distance of 0 and a fare of 52. Kind of strange, not really sure why that's there. There are a lot of points like that. Maybe if somebody knows in the comments, you can let us know. But, okay, we can say, well, what would you estimate is the slope of the line of best fit for this data? So let's just pick 2 points that we think lay on the line that are also easy enough for us to compute. So let's see here. Let's say I have a distance of 0 and a fare of 2.5. So I have the point 0, 2.5. And let me put this in dollar signs. And let's see another point. Let's see something that's maybe easy to compute or write down. Let's see, maybe 15.05 and 42.5. So 15.05, 42.5. So I'll say here we have the points. So to compute the slope, let's do 42.5 minus 2.5 divided by 15.05. So it's saying here the slope of this line is about 2.657. So we'll perform linear regression and see what slope we get there, but that would be my estimate for the slope of the line of best fit. So next we're going to do is we're going to find the slope using linear regression from scikit-learn. But first thing I want to do is introduce a workflow in scikit-learn that we will see many times starting right now. So what is this workflow? Well, step one, as you might expect, is we're going to want to import things, right? So one, I'm going to say import. So again, like you would expect, we need to import things. Two, we're going to instantiate. So like we've seen this when we create instances of RNG objects, but here we're going to create an instance of an object from an appropriate class. Third, we're going to fit. Basically, we're going to introduce our data to the model. And four, we're going to predict. So we're going to use our model to predict outputs. So see here, this problem, find this slope using linear regression class from scikit-learn. We'll start by importing. So I'm going to say, tag this with import. Now from sklearn dot linear underscore model, import linear regression. And we got the green check mark, so no issues there. Next, we're going to instantiate. And I'm going to say reg for regression is equal to linear regression. So we're creating an instance of a linear regression object. And I could type on reg. And we can see here, this is a linear regression object. So this is not in base Python. This is special to scikit-learn's linear regression. I'm just going to turn the page in my notes really quickly so I don't forget to say anything. So what we're going to do next is we're going to attempt to fit the data. But we're going to get an error, and this is a super common error and one that I suspect you will get many times as well. So I'll say try to fit, but get common error. So I'm going to say reg.fit, and I want to fit, so distance. So I want to input distance and predict fare. So I want to know, you tell me how long the taxi ride lasted, and then I want to be able to predict the fare. So let's see what happens here. And it's saying expected 2D array got 1D array instead. So what's happening here is it expects that our inputs are a two-dimensional array. And let me try to convince you that df of distance is one-dimensional. So if I do something like dot shape, and let's see, so deep note wants to be, let's see, there it goes. Okay, good. So notice we have this blank second entry of the tuple. So this is kind of telling me it's one-dimensional. Versus if I try something like df of df distance, so I pass a list, it's a length one list. But notice now this is seeing it as a data frame object versus df of distance is a series object. So now if I try something dot shape, we can see here, even though it still has one in this second entry of the tuple, it's recognized as two-dimensional. So one way that you can remember that this two-dimensional object is expected is if I do reg.fit, and notice what pops up. We have capital X that's telling me it needs to be two-dimensional. Lowercase y is telling me that it doesn't expect the two-dimensionality. So I'm going to do df, again, pass a length one list with just distance. And again, my target is fair. All right, so it worked. We don't see anything yet, but basically what's happened now is Reg has done all of the hard work for us, and we're ready to go. So what we can do is we can look at the slope, and it's stored in the coefficient attribute. So I'll show you how to do it. I can do reg.coef_, and it's telling me that the slope of the line it got. So basically what this has done is it's done all the hard work of finding a linear equation that approximates our data. And it's saying the slope of that line is 2.73. And that should make sense because remember, our approximate, when we just kind of eyeballed it, was 2.65, so pretty close to 2.7. So that's looking good. You might notice that this is a NumPy array. If we fit to multiple input columns, then we would expect more entries in this array. So we'll see some examples of that in an upcoming video. But let's say I just want to get the number. I could do reg.coef and then just say, give me the first entry, the 0th entry, and that's how we can get the number. If I wanted to get the intercept, well, this is stored in the intercept underscore attribute. So I could do reg.intercept. Oops. And it's saying here, intercept is about 5. So now what we can do is let's see how well the model does against our data. So I'm going to just look at the first 5 rows. And we see here, okay, so we have distance and fair. And maybe let's just take as an example. So I have a distance of 1.6. So what the model will predict, so remember, this is going to be the linear function. So I have the coefficient, so reg.coef, and then take 0th entry, times the distance traveled, so 1.6, let's say, plus the intercept. So this is just mx plus b, equation of a line. And it's saying the approximated fare would be $9. So here it was actually 7, but not terribly off. If I wanted to get more estimates, what I could do is I could say reg.predict, and then I say predict based on df of distance column. And again, same issue here. It needs to be passed as a length 1 list. And I'm going to say df of pred for predictions equals this. And then what we can do is let's take a look at, again, just first 5 rows of df. So again here, so fair, 7, estimate is 9. And maybe let's also just look at fair and prediction. So it's saying fair, it was actually 7, predicted to be 9. Here it was actually 5, predicted to be 6. 7.5 predicted to be 8. So not bad, huh? All right, I think this is a good place to stop the video. In the next video, we'll talk about kind of how to interpret coefficients from linear regression. So thanks for watching, and I'll see you there.